Okay guys, now let's try and understand colloids. And in colloids, let's try and understand solutions first. Now we are going to deal with two types of solutions. One is transparent and other one is translucent. If I take sugar and put it in good quantity of water and stir it well, I would find that I would be getting a clear solution. Okay, same way, milk. Okay, milk you take, put it in water and stir. Always you would find a translucent solution. In case of sugar solution, it would be transparent, whereas in case of milk, if you keep on adding water in milk, still the solution would be translucent. Why is it so? Transparent solutions have solute particles with diameter in range of 0.1 to 0.2 nm. Nm is 10 raised to minus 9 nanometer. Alright. What about translucent? What about milk? In case of translucent solutions, solute particle with diameter in range of 2 to 500 nm exists. Alright, so that's the main difference. It's the particle size which is important for making a solution transparent or translucent. Alright, okay. Now let's move to part B. Okay, let's get into colloids. Now, before getting into colloids, we have got to get used to some terminologies. Alright, that is dispersing medium, dispersed phase and dispersion. Now, this is what is dispersion. Now, what we have taken is colloidal solution of starch. Alright, so these are all colloids of starch. So these are all called as dispersed phase. Alright, and this is dispersed in dispersing medium. Dispersing medium is water. Alright, and the entire system is called as dispersion. Now starch, we have already seen starch. It has 200 to 500 nm. So it's translucent. So it would be translucent. So we have colloidal solutions like milk, starch and so on and so forth. Alright. So we learned dispersion, dispersing medium, dispersed phase, and that is what is colloid. So let's get further now. Colloidal particles tend to be electrically charged. Alright. As these particles tend to attract charged counterions or dipoles of dispersion medium. Alright, I have just taken two examples which are in nature. Alright, okay, hemoglobin. Hemoglobin is positively charged. Sol. Sol we know, sol is solid dispersed in liquid. So hemoglobin is positively charged sol and starch is negatively charged sol. Alright, so colloidal particles are mostly charged. And if they are charged, why? Because they attract charged counterions on their surface. Alright, charged counterion or dipoles. Now for example, water. Water is a dipole. Water has got O which is negative and H which is positive. So it's a dipole. So it would attract dipole accordingly. Like if a hemoglobin is there positively charged, then it will bind itself to oxygen. Alright, and since it would be binding to oxygen, so H plus would be outside. Alright, so again it would be positively charged. So that's just one of the way that colloidal particles gets charged. Alright, by attracting counterions or dipoles. Alright, now let's get into a bit of its application, that is electrophoresis. Okay, now electrophoresis, now it consists of U tube, alright, which has got two platinum electrodes. Positive is anode, positive is anode, negative is cathode. Alright, so there's electrical potential over here. The tube is filled with colloidal solution. Alright, now what happens? Now we assume that the colloidal particle here are positively charged. Alright, so what happens if I want to dispersed phase is positively charged. Alright, now positively charged means obviously we saw hemoglobin. Alright, we saw hemoglobin to be positively charged. So it has got positively charged colloidal particle. Now what happens is, as electrical potential is applied, molecules of hemoglobin would be moving towards cathode. Positively charged molecules of hemoglobin would be moving towards negatively charged cathode. Alright, now that it would do. But then if there are other molecules also which are positively charged, then there would be separations of layer. Now what sort of separation of layer? The smallest particle would be forming the topmost layer, and then the larger and largest. Alright, so this way what happens is, by electrophoresis, not only are colloidal particles separated as per particle size, but also the dispersion medium is on the other side. Alright, and the particles are on this side. So again there is a separation. Alright, so what is electrophoresis? And we find that the particles also deposit on the electrodes. The smallest particle would come and deposit on electrode, and then the layer would be forming. Alright, smallest, then little bigger, and biggest or largest. Alright, just let's see what is scribbled over here. Movement of colloidal particles under an applied electrical potential is electrophoresis. Movement of colloidal particles under applied electrical potential is what is electrophoresis. Alright, now let's get into electroosmosis. Before we get into electroosmosis, let's recap osmosis. Osmosis was what? It was movement of water molecules from solutions with high concentration of water molecule to solution with lower concentration of water molecules. Alright, just to understand, I've taken a small example. Now aluminum sulfate 1 molar solution over here, sodium chloride 2 molar solution over here. Now when I say molar solution, now you know the concentration is more, so water would be less over here, so it would be flowing from here to there. But let's understand what's the fact. Aluminum sulfate has how many particles? 5 particles. Why? 2 of aluminum and 3 of sulfate. So it has 5 particles. And what is its concentration? 1 molar. So I just multiplied that 1 with 5 and I got 5. Alright. Then in case of sodium chloride, what happens? It's a 2 molar concentration. How many particles? Sodium and chlorine, 2 particles. And what molar? 2 molar. So I multiplied it with 2. So what I got is 4. Now 4 for sodium chloride is lesser than 5 of aluminum sulfate. So if it is lesser, then obviously water concentration is more over here. So sodium chloride has more water concentration than aluminum sulfate has. So obviously water would flow from here to there. So this is the direction in which water would flow. Alright. So this is what we have read in osmosis. So what is electroosmosis? Electroosmosis also has got to do something with solvent. Now the solvent moving out through a membrane. So this was a membrane. I forgot to mention probably. This is a membrane. Alright. Mostly we use biological membrane. Alright. Okay. Now let's get into a process called as electroosmosis. Electroosmosis, obviously, now see, it's the same thing. It's a membrane here, semi-permeable membrane over here, colloid over here, colloidal particle over here. We have got a dispersion over here, and it is connected to electrodes to generate electric field. Alright, this is the difference there. So now what happens? Now suppose this is positive terminal, this is negative terminal, and as electric field is on, we would find that negatively the colloid particle would stay there, and the dispersion medium would come out through the membrane here. So this is the compartment where we would find colloidal particles, and this is the compartment where we would find dispersion medium. Alright, so movement of liquid through a membrane under influence of electric field is electroosmosis. Alright.